Hello and welcome to another episode in our series on elementary arithmetic, where we're slowly building up the core concepts of what you'll need as you grow up to have confidence in basic arithmetic skills. You might be a student in this situation at this stage, wanting to learn how to work with integers and will systematically increase the complexity of what we can do. Or you might be an educator, a parent, wanting to help a student, but not being sure where exactly to start, what is important and what is less important. What is important is single, simple methods that will always work. It might not be the fastest in every situation, but by focusing on the core, simple methods, we can build confidence in them and later on be a little bit more sophisticated with mathematical tricks down the line if we ever want to. So previously we have discussed the number line model as a model for basic integer arithmetic. We will now talk about an alternative, the chip model, where we're going to use multicolored chips, two different colors. One will indicate a positive chip. For example, let's take yellow as our positive chip. Let's write here, this will be, and this may be yellow. Yellow will be a positive chip and will count positive integers. And then we also need to count negative integers. And this will be done with a different colored chip. Let's use a red one. Apparently it's a little down. There we go. So this is an alternative to the number line model because some could argue that the number line model is in a way somewhat abstract. The chip model gives me, in certain situations, a more direct feel for how these integers are interacting with each other. Let's clear this up and get rid of these chips. And let's think of the story. Think of a practical story. Let's suppose you are in elementary school and you have, let's say, pieces of candy. You have 3 pieces of candy currently in your bag. So it's a positive quantity. The teacher is very generous today, and she's going to give everyone 2 more pieces of candy. Your turn comes around, and in addition to the 3 you had, she puts 2 more pieces of candy on the table. The very basic elementary question is, how many pieces of candy are on your table? The benefit of the chip model is that we can interact with these objects and act out the story of this addition calculation. Now, with addition and both of the integers involved being positive, that is certainly the first very simple situation. So how the chip model would work is we're simply acting out what is happening on the table. And so we have our starting amount. In this case, in our example, let's remember we had 3 positive chips to start with. Now we plan, according to the operation, we plan to do what this addition wants us to do. And in the chip model, it is always the same. I plan to put more things on the table. Or in this case, in our story, the teacher puts more things on the table. So more things will be added to the table. Then I look at the next part of the instructions, and this is, let's say here, what to place on the table. And as our story suggested, we then get 2 more pieces of candy on the table and then simply count how many there are. So that is certainly the basic and the core idea in the chip model. It's more interactable, it's more directly, practically relevant, and some people really appreciate that aspect of it. Let's tell a different story. Let's first tell the story and then indicate what was the calculation behind that story. You start with 3 pieces of candy in your bag. This is your current starting situation. You like to play games. You play a game with your friend and you wager 2 pieces of candy. Unfortunately, you lose that game, so now you have added some debt of 2 pieces of candy that you have to settle with your friend. So in addition to the 3 pieces of candy that you had, you have a debt of 2 pieces of candy, and you need to settle this before you can finish the day. So this one debt can be paid off with the 1 piece of candy, and that's gone. The other debt can be paid off with another piece of candy, and now those 2 are gone, and you are left with 1 piece of candy in your bag. The value of what you have in terms of candies is 1. So let's see what is that in the chip model. Well, we have our example that was starting with 3 and adding debt, and debt will be represented by negative chips. Again, we have our first step of starting with a certain amount. We started with 3, if I can line them up carefully, 3 pieces of candy. Now, we are looking to add. So we are going to put more things on the table. What do we put on the table? We put 2 negative chips on the table. They do not want to sit next to each other. There we go. So in this case, contrary to what we had previously, we don't have a value of 5 on the table. We need a cleanup 4th step, where positive and negative pairs will cancel each other to determine the value of what we really have. So those cancel each other, and these guys as well will cancel each other, and they're now off the table to give us our value, as we have previously, of 1 positive chip. So in the chip model, it's simple in that addition will always put more things on the table. But it also depends on what I started with and what I am putting on the table a little bit later. Let's look at some subtraction. So let's just start. Actually, no, we're going to leave subtraction for now. Simply to not have the video be too long, we'll do subtraction in the next episode, let's just do a couple more for addition to make sure everyone builds this foundation carefully and in a very solid way. Let's say -4 plus 1. Now, it really helps your understanding to imagine a story associated with this calculation. The benefit of the chip model is that it is practically more relevant. It more closely resembles a practical situation. So in this case, my week has not been going well. I've been placing bets with some friends, friendly wagers, but I've not been doing well. And I start the day with 4 debt. Now, I still have 4 debt because I can't settle it yet. But my friends are pretty patient, and they'll wait, but the debt's not going to go away. Again, I got the teacher in a pretty good mood. Not a great mood, but a good mood. And they're going to give every one of us 1 piece of candy for free. So they come around to my table, and I get 1 piece of candy. What is the value in candy of what's on my table? Well, in order to see that more clearly, I can settle some debt. I don't want to overlap them. I can settle 1 debt with the candy that I now have. So let's get rid of them. I pay off 1 debt, and I still have a debt of 3 as my worth, my value in pieces of candy. So again, notice how the addition doesn't change. I'm always going to start with some things on my table, be they red or yellow, positive or negative integers. If I add, I'm always going to put more things on the table. The second number may be similar kinds of chips to what I had. It may be different, and then there is some cleanup required. So the cleanup is not an optional step, but it may not happen every time. So let's wrap this up by clarifying the steps again. We have our starting amount, and we have the instruction to put more on the table. Then the second number is what we put on the table, what to put on the table. And before we can finish, technically, there is a possible, that is a lovely word that I can write more neatly, for sure. Let me try. Possible, let's put it somewhere else. Can I move this? I just moved the S. There, we're going to try again. I didn't realize it was blocked by the cat. There we go. Possible cleanup. Depending on what I've added to the table, what I started with, there might be this cleanup phase in the chip model to see how much in candy, in chips, whatever, how much I actually have. All right, that is a good place to pause here. We will follow this in our next episode by looking at subtraction specifically and the stories that are associated with the chip model. Until next time.